what Airbus did was using an algorithm based on fungus growth, which I thought was quite interesting, to reduce the materials used in their cargo doors. So the in-flight doors of an Airbus A320, I think it was. They mapped that in a CAD program and applied an algorithm to it. And the algorithm was able to minimize the material used by 45%. And by that, they reduced their CO2 emissions by 166 tons of CO2, which is quite amazing.
Welcome to Somewhat Overfitting, the podcast about data science and digital transformation. This show tackles questions to help us better understand the field of data science. I'm your host, Jonas Witt. AI can be used in many ways, from finding the best search results based on a keyword, over recommending the next movie to watch, to driverless vehicles. Another field for applying AI is innovation management. Today's guest writes in the introduction to his thesis, AI not only offers the potential to generate new innovations, but also an approach to disruptively change innovation management. The name of today's guest is Moritz Schuster. Moritz, who goes by Mo, did a master's at Fordham University in creative communication and brand management and is one of my best friends. The research question of Mo's thesis was to figure out if and how AI can support or replace humans in each step of the innovation process. In our conversation, we talked about his definition of AI and innovation, and we also discussed the innovation process he derived from his research. We went through each step of the innovation process and discussed if and how AI can help in each step. At the end, we also briefly touched how human-machine interaction will look in the future and also discussed the social impact this might have. So, let's get started. All right. Mo, thanks so much for being on the show. Before we dive into the topic, would you give us a short introduction to yourself?
Sure. Thanks for having me. Yeah. My name is Moritz Schuster. I'm 26 years old. I studied creative communication and brand management at the Hochschule Pforzheim, and this is where we actually know each other from. I finished my master's last year with the Thesis, and I think that's going to be the main topic we talk about today.
Yes, it will indeed. So the topic of your thesis was AI, so artificial intelligence in innovation management, or in the innovation process. Could you give us a short introduction to the topic, to the research question, to the methodology, and maybe also to your motivation, why you chose that topic?
So, yeah, you're right. The research question was to find out about the potential of the AI usage in innovation management, specifically applied to an innovation process. It was a two-part thesis. First part being a literature review about the two main topics, which are AI and innovation management. And from that, I was leading into the topic of the usage of AI in innovation management. And then in the second part, deriving results from the literature review, and then also proofing or questioning these results in expert interviews, the experts coming from research facilities and industry representatives in Germany.
In the thesis, in the theoretical part, you define on one side the innovation and on the other side the AI, the artificial intelligence. Could you first define innovation in the sense of your thesis?
Innovation, I think most of us would think of an innovation as this technical invention, actually. And like the iPhone, for example. I added a more holistic approach to it. So I had a more economic viewpoint to it. And I was defining it as something new. So it doesn't have to be something physical. It can also be a process innovation or a social innovation, and something new that proves itself in internal use, for example, for processes, or that can be successfully commercialized with products in the market. And innovation management then is the design, management, and development of innovations and their corresponding processes.
In your work, you're describing a process that you based your research on. Can you describe that a little bit, as we are focusing on how AI can support that process?
So again, innovation process as a holistic approach. So I'm not starting with generating ideas, but there's also earlier stages in innovation management, which is an initialization stage, where you basically have to find out about problem space then analyze a given problem, and then derive ideas from that. And then in the end of that process, you have to, when you have an idea you want to work on, you have to question that idea, find out what the best solution or way to exploit that idea is. And then at the end, basically you go into commercialization, which means you have a final proven MVP, minimal viable product, which you can then implement in the market.
So to summarize, the process would be first step in initialization, second step problem analysis, third step is the idea generation and the idea evaluation, fourth step is the idea implementation, then fifth step is testing and validating the idea, and then the last step is to commercialize the product and to bring a MVP to the market.
Pretty much, yes.
Perfect. And then the other part of the thesis is artificial intelligence. Could you give us a short introduction on what is AI in the sense of your work and what is AI not in the sense of your work?
There's quite a few ways to define AI, and in literature, which I read quite a few of, there's many ways of defining AI. So what I'm saying, this is just my way of defining AI. I'm sure there might be quite a few different ones, but this is the one I found most suitable. And for me, AI, or artificial intelligence, is mostly an umbrella term for basically any technology that allows computers to mimic human intelligence. That could be, for example, a robot or an autonomous car or a drone, but it doesn't have to be physical. But it's important to implement robots as well. In my definition, I think we're going to talk about that later. Then a subpart of artificial intelligence is machine learning, which applies to the part of AI around algorithms that can gain experience and improve via data. For example, in an autonomous car, that would be the algorithm that interprets the image that it's receiving. And then another subpart of machine learning is deep learning, which translates to that part of the algorithms that involve convolutional neural networks with multiple hidden layers, which the algorithm exploits to learn, basically.
And so you say, in your sense, artificial intelligence includes robots, so also automation techniques?
Yes. You also asked me what it's not. So when we're talking about is artificial intelligence automation, I would say no. Let's take marketing automation, for example. I would say automation, for example, automated newsletters to customers that have been classified as to a different target group and targeted based on their socio-demographical backgrounds. That's not AI, that's just automation. But then AI would be if, for example, we would create 3D models for the target group we were defining based on given images, but the models we create, they don't exist. That would be AI. It would be also a highly skilled chatbot, for example, in customer relationship management that can instantly and correctly answers the questions of the customers. Then yes, that would be AI. But automation, no, that's not AI.
Mm. And then a robot, for example, in the car manufacturing space that puts in glasses or doors into a car, is that then a automation or is that artificial? Has that some intelligence?
Under my definition, it would be AI. That's the point. There's a lot of definitions to it. There's many people who would argue it's not AI. I would also agree with them. Maybe we can say the processes, the technique, or the algorithms that operate the robot, that's AI. And the robot itself is just like the physical tool that moves. But for my definition, it was important to implement it as well, because I will talk about use of cobots and human machine interactions later on. And then it's important to have the physical part as well.
Okay, that makes sense. So based on that definition and based on your research, what are your top 2 opportunities for AI to support a company or a business? So
what I found out was the biggest opportunity for AI to support companies is that it can increase their efficiency by a lot. And there's many ways that AI can do that. First one being it can automate processes, which we already talked about. An example being any task that was previously made by humans can be outsourced to machines. That can be customer support, chatbot, for example. Then we have the opportunity that it can scale up processes. So, for example, when previously one customer supporter was talking to one guy each time, one chatbot can now talk to 100 people at the same time, which scales up the process by a lot. It also helps efficiency by speeding up processes. For example, any process that requires a lot of documents to be analyzed and read, an AI can do that very quickly and very effectively. So you have shorter reactions times in processes, and you gain opportunities by basically shortening your processes. So you have an effective way of dealing with huge amounts of data. That's the first one. And the second one is that it can unlock hidden innovation potential, which is a big topic of my thesis, because AI will not work in ways that your fellow workers used to for the last 10 years. So, well, at least not if you don't tell it exactly to, which is quite hard, I think. So it will break out of traditions and give you a different approach to problems, I think.
So considering that specifically, like more efficient, quicker, and therefore AI can reduce the cost of a company. You write in your intro to the thesis that specifically in Germany, not a lot of companies have implemented AI yet. And that brings me to the question: what are your, again, based on the things you found, what are the top 2 challenges of implementing artificial intelligence?
I think there's a short and a long answer to that. Short being you have to have the right data and the right people that can work with it. And also you have to find the relevant use cases for AI. That's a short answer. And the long answer would be, depending on the maturity of your enterprise, provide all the necessary enablement factors. The first one being having a good infrastructure, which means basically having a big data warehouse where you can make all the data available to all your workers. Second one being to have the know-how and a talent pool that is focused on learning. So there's not one AI silo in a company. And third one being to have a good management team that sees the long-term value of AI and does not say, yeah, let's do something with AI and see what we will get out of it.
Having talked about the definition of AI and innovation, let's move to the next part of your thesis, which is the main part of your research, is AI in innovation. So we discussed earlier the innovation process, the 6 steps of initialization, the problem analysis, idea generation, idea implementation, test and validate, and the product launch. Not the product launch, the product launch. So let's go through each step of the process. And can you give us, for each step, an example of those use cases? As you said earlier, finding those use cases is one of the challenges with AI. Can you give us an example how AI can support there, and maybe also a use case example? Let's start with the first step of initialization.
Yeah, and I think that's first quite a big one. So initialization basically means you have to define a relevant strategic innovation search field. At least that's the translation from German. It means that AI can basically scan your environment and find opportunity spaces. So AI can find trends that emerge from any topic, basically. AI can analyze patterns that will be announced from companies, and AI can analyze startups in your environment that come up with relevant new technologies to tackle certain problems. So that's the big thing in the initialization stage, is environmental scanning. Big part of environmental scanning is NLP, which translates to natural language processing. So for example, patent analysis there's a lot of databases where companies announce what patents they analyze. Actually, they have to. And
so the company, if they analyze patents, they need to document which patents they analyze, or is it they need to register the patents?
When patents are registered, you will find out, for example, emerging patents that are coming up right now are foldable screens. So Apple, Samsung, I don't know which companies, they announce a lot of patents for foldable screen technology, and that is open source. So basically everybody can see into those patterns if he looks for it. And AI can help you analyze those patterns. For example, what is specifically relevant in that pattern, but also it can analyze how many patterns around a certain topic come up. So, for example, if in the last year there have been 500 patterns around foldable screens, an AI can tell you this is an emergent trend that could be relevant for your idea generation, basically.
And then based on that, you can go to the next step, which is problem analysis, and think about how your company can jump on the train of, for example, foldable screens.
Exactly. Problem analysis is quite simply using AI in your company to analyze how you can tackle certain problems, showing you what existing data you have around that topic. So it can basically tell you, it can analyze all your internal documents around foldable screen technologies and also available technologies to in production, for example.
So it goes into what you have and summarizes that, or does it also make a connection to what you found in step one?
In theory, both, but actually I didn't find many use cases to it, so I can't tell you exactly how it is implemented, because it's basically just the question of how AI is used in analyzing internal data.
And then so in step one and step two, AI would mostly be used for text classification and text summarization. So I
think that's the biggest one, yes. Yeah. There's also foresight processes, which use the information you analyzed to create opportunity spaces. So given on the data you found, they will create scenarios and open up these so-called opportunity spaces or idea spaces. So that's basically, I would call it a cluster analysis to show you on which bigger topics you can focus.
And what the things that you found, was that mostly based on use cases, or was it mainly based on research papers?
That's the thing. There's a lot of theory and there's not many use cases, especially in Germany, because I think in Germany, many people are talking about using AI. There's a lot of startups showing you the opportunities, and there's not many use cases to back it up. So in theory, it all works, but basically they just can't realize it.
So the next step is the most interesting one, because that's where the creativity comes. The next step is the idea generation and the idea evaluation. And what did you find how AI can help in that creative process of coming up with ideas to innovate?
Yeah, so basically it just follows the lead of the problem with the foresight processes and the problem analysis. So as of now, it's hard to find relevant use cases for idea generation in AI, but there's a lot of cases where it is used in idea management systems. So again, clustering ideas that came out of manual processes where innovation managers basically summed up their ideas, and then an AI can cluster those ideas and help find other solution spaces. But coming back to the definition problem, if a cluster analysis is AI, it's debatable. There is some ideas how AI can be exploited in idea generation, one of them being simulation. So there's, for example, AI-generated design, which gives you, based on a problem, lots of different ideas or solution opportunities to solve, for example, the problems of minimalization of material usage in car doors, or cost reduction in logistics if we want to tackle process problem. But being creative as an AI, I don't think that's possible at the moment, but will be in future.
Mm-hmm. The next step in the process is the idea implementation. What did you find out about the implementation of ideas and how AI can support those steps?
Let me think about the last question again, because I think in the idea generation, the perfect world would be, for example, I'm a fashion brand like Adidas, and I want to create the next fashion hit for the summer. And I would just throw in my data to AI, and it would tell me what the next summer sneaker for 2020 is. That's the ideal opportunity, but that's not how it works as of now. But I can lever ideas from AI. For example, I can analyze customer feedbacks on my products. I can use trend analysis and then generate ideas based on what I have on my data. And that's basically NLP combined with AI-generated designs. And I think that is the perfect way how an AI would help in idea generation. It is possible in theory, but as of now, it is not commonly used, but will be in future.
So AI would mostly help in managing the ideas and in analyzing feedback on the ideas.
Yes.
All right. In the implementation of the ideas, how can AI support there?
Yeah, so that's basically the robots or cobots I was talking about earlier. So a human doesn't have to make all the manual steps in production, but it can be helped. But also it doesn't have to be a production step. It can also be in elderly care. If a caretaker would, for example, have to move a patient from point A to point B, a cobot would be a machine that would help the caretaker to lift up the patient, for example, and help him moving. But that's basically just using some physical machine to help in implementing the product or process. But yeah, that's a simple one, I would say.
You are writing one, or you are mentioning one example from Airbus that uses AI to help them create lighter material. Can you describe that a little bit?
Yeah, that's the AI generated design, which I think is quite interesting. So again, question of definition, is it idea generation or is it Umsetzung? You can argue there, it's a whole lot of different definitions, but it doesn't matter because the use case is awesome, I think. So what Airbus did was using an algorithm based on fungus growth, which I thought was quite interesting, to reduce the materials used in their cargo doors. So the in-flight doors of an Airbus A320, I think it was. They mapped that in a CAD program and applied an algorithm to it. And the algorithm was able to minimize the material used by 45%. And by that, they reduced their CO2 emissions by 166 tons of CO2, which is quite amazing.
Yeah, that's pretty impressive. Yeah, I thought that as well when I read that part. Is it actually the implementation or is it more the idea generation? But then you could, like you say, it's a definition thing, and then I think you could say that the idea is making it lighter, and then the implementation is the algorithm.
I think that's one thing that you can criticize about my thesis. The process I generated, it is not certain that these are exactly those phases. But I think it doesn't matter because it's just about a whole process and certain points where AI can be applied. So define it how you want, but the use case is awesome.
Yeah, that is definitely true. And I feel like the definition is, as long as in the end a good product comes out, it doesn't matter in which phase of the project you did what, and if that is in theory correct or not. So the next phase would then be a test and validate. What use cases for AI did you find in that phase?
There's, for example, simulation. So if you want to test a product, but you don't want to produce it before you test it, because there's a lot of costs applied to it. For example, if you want to test an airplane, you don't just produce an airplane and then test it. Maybe that's the way to do it now, but simulation would be a much better idea because you can basically just simulate everything, how airplane design would behave under certain circumstances that you can't even recreate in real life. So simulation is one big part of testing and validation. In production, the pendant to it would be called a digital twin or a digital shadow. So every physical asset you would produce, there's almost certainly a digital twin to it that you can simulate in some sort of program. And yeah, you can test that before you produce it, which is the AI use case.
And now, lastly, the product launch or the commercialization. How did you find AI support there?
There's a lot of ways, which we partly already talked about. For example, in marketing, there's a lot of ways where AI can be applied. In logistics, there's a lot of ways that AI can be applied in processes to minimize distances or shorten times or reduce costs. There's many, many use cases, and I didn't mention those specifically because, again, definition question, is it still in the innovation process? Some would argue yes, some would argue no, but also there's so many use cases that I can't mention one specifically, but I think AI has a lot of potential to be exploited.
And then one thing for the commercialization would be, for example, a chatbot. I understood.
For example, yes, it doesn't have to be, under my definition, it doesn't have to be an AI product. So, for example, it can be a finished airplane, which doesn't involve AI, but it could be.
Yeah, perfect. And then in the process at the end, in the commercialization, a chatbot would be the AI that supports in that phase. For example, if the product is a humanly designed sneaker, a chatbot would be something that can help a Adidas launch in the product launch of the sneaker.
The chatbot would be a process innovation because the chatbot is innovating the customer relationship management. So it's an innovation in the process, not in the product itself.
Mm-hmm. Okay. So it seems to me like that the innovation process is in some way rolled backwards with AI. What I mean there is that the AI technologies are the amount of use cases or the amount of how much AI is implemented is higher in the later stages of the innovation process. Would you agree to that? And if yes, why do you think is that the case?
Yes, I would agree. And I think that has to do with the complexity of the tasks that AI has to solve. So, for example, in the later stages or in the commercialization of an innovation process, you can map AI to very low complexity problems. For example, solving a logistics problem is for an AI a very easy problem. But then in an early stage of an innovation process where you have to come up with a solution space for a problem that exists or doesn't even exist, that is a much higher complexity task. And the higher the complexity of the task, the harder it is for an AI to solve the problem.
After talking through that process, where do you see the highest potential for AI?
In the later stages, the commercialization, there's a lot of potential, but as of now, also in the early stages, some would call them the fuzzy front end of innovation, the trend management, pattern scouting, etc. There's a huge potential for AI there because there's a lot of data to be processed. I would more see it like a U shape. If you see high potential, low potential as your x-axis. So in the early stages, a lot of potential. In the later stages, a lot of potentials. In the middle stages, the creative ones, as of now, not. But I think in future that could be changed. And talking about radical and incremental innovation, especially in future, I think there's a lot of interesting opportunities for AI to come up with different solutions.
In the work, you also touched a little bit on the topic of human-machine interaction. What do you find? How can human and machines work best together?
I think the most effective way of human-machine collaboration is when the machine can assist the human in a way that he can use the time he would have spent on more robotic tasks like moving numbers in spreadsheets or physically moving an object from point A to point B for more meaningful tasks or creative tasks. So basically give the AI a problem that it is good at and make some space, make some time for the human to solve more creative, more meaningful tasks.
And that also brings us to one point, which is, I think, important to mention when you talk over AI is the social impact. It is not necessarily the focus of our conversation, but based on your research, what are some social challenges you found around the topic of implementing AI?
So basically getting rid of biases in algorithms and being able to explain them. Also, a problem with biases is it's always a person who programs the algorithm. And if a person is biased and programs a biased algorithm, you can have the best AI that still will be biased because of the programmer. Also, social challenges around AI is there's many people arguing that we will lose our jobs to AI. So basically, everybody's task will be done by a robot once, and I think that's mostly false. Surely there will be jobs in future that will be completely automated and taken over by robots. But I think I would argue most of the jobs future will be done in collaboration with AI, not taken over from AI. However, I'm sure that the human role will change in future, and we have to question ourselves, what is our role in the future in working together with machines and algorithms? So, for example, maybe the job of a truck driver will be taken over from a robot, but the truck driver then has to come up with another job which could be repairing the truck. And the social task there is that in order to repair a truck and not to drive a truck, you need a much higher education. And I think that's another social challenge around AI. Also, there's political challenges, regulations on AI on a global stage, for example. That's a huge topic. And environmental challenges, which are quite interesting because all these algorithms, they need a lot of computing power, of course.
Yeah, I read about that recently as well, how much power sometimes an algorithm needs to be trained. And then the question is, if a algorithm is supposed to be helping reducing the carbon emissions, does it actually do that? Because there is so much greenhouse gases emitted when trained.
It's an interesting topic because I found a study where it says until 2040, almost half of as much of our CO2 emissions will come from digital media. And then again, I think AI can be used to lower CO2 emissions. There's some really cool projects, for example, trees being planted by drones or wildfires being predicted and prevented through image analysis of the AI. So I think it really is a question how we use AI in the future to prevent environmental or climate change with AI. That's a big question.
So in the end, the question, will AI replace humans, you already kind of answered, is that some jobs, yes, but not all the jobs. And then the social challenge is there to help the jobs or the people who are losing their jobs due to AI to help them find a different job.
Exactly. I think AI needs the human to evolve, and the human needs the AI to tackle the big challenges that are ahead, like climate change, for example, starvation. There's a lot of cool potential use cases for AI, but we don't have those use cases right now.
Great. That was a great conversation. I would like to ask you a couple more questions at the end. And that would be first, what is something that surprised you the most during your research?
Most surprising for me was that AI is a research topic since 1956. So almost it's more than half a decade, century, sorry. And actually, there's still so little knowledge in enterprises about it. And there's huge potential in the technology. And it's like in the last 10 years or so, it's just being exploited because of like the computer power we have right now. But as of now, there's not many people that know how to operate and work their way around data and AI. That surprised me that such a important and powerful tool has so little knowledge around it and so few people that can work with it.
Would you also call that one of your most valuable learnings from your research, to get an idea and get an understanding of that topic?
Yes. And for me personally, I think my most valuable learning was for me to demystify AI. I think for many people, as of now, AI is this black box. For me, before my research, for me, AI was this magical tool. I could ask, hey, I have a problem. Please solve me the problem. And then I give it to the AI and it comes up with this great solution. And when you learn about AI, you know that it's like a whole lot of difficult mathematics, a lot of algorithms around it, but it's not magic. And there's a lot of cool stuff that can be done with AI. And I think that's what I want to basically say. I can only motivate anybody who's listening to this podcast to just play around with AI and to, like, get a grasp on it on a playful way.
Getting ahead of my questions, and the last question would be, is if there's anything you'd like to add.
Yes. So exactly that. I think here in Germany, we have a very conservative way of thinking about AI when it comes to that. Like, many people are scared of Alexa, and they would be very reluctant to enter an autonomous car or something. And I would agree with them in some ways. Like data protection is a big thing, and I'm not sure if I would enter an autonomous car right now, because the technology might not be that advanced yet. However, I would empower people to just play around with AIs. There's some really cool tools around. There's, for example, the teachable machines from Google. I don't know if you know that. Do you know the tool?
No.
It's a great way. I think you can go online and just basically play around with your webcam and train an AI to recognize whatever you show to the camera. So basically, you can train it to recognize an arrow to go left or to go right, and then apply that algorithm to some creative projects. So, for example, there were people that trained with this teachable machine an algorithm to open a cat door for their cat, or feed their cat, and not feed any squirrels that came up.
And that's something that I need.
So I think there's some really cool ways to demystify AI and have some fun with AI. And I think if people get like a playful and curious approach to AI, I think in the future that would be great to demystify that big question mark, which was AI for me.
Perfect. I'm going to put the link to that teachable AI tool in the show notes. And where can people connect with you?
Where can people connect with me?
Yes.
I am on LinkedIn. I think that would be my primary connecting tool. I'm also on Xing for my German friends.
Yeah, thanks so much for the insights. That was a great conversation. And thanks so much for being on the show.
Thanks for having me.
All right, that would be a wrap for this episode of Somewhat Overfitting. Thanks all for listening. If you like the show, please subscribe wherever you listen and rate and review it on podchaser.com/somewhatoverfitting. Thanks again to my good friend Mo for being on the show. I highly agree with Mo that trying to understand data science and AI demystifies the topic. I'm looking forward to see more NLP and text processing in action for trend watching and for knowledge analysis within a company itself. Let me know what you thought about this episode on somewhatoverfitting.com. There you can also find today's show notes. The theme song is from Bobby Rands and is called Jungles. Thanks again for listening, and see ya.